Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of derivatives. So as per the problem, determine an equation for the tangent to each function at the point with the given x coordinate. So let's start with part A. So in part A, the given function is f at x equals tan x and the x coordinate is pi over 4. So we have to find the equation of the tangent to this function f at x, and we know that tangent is a straight line and its general equation in slope intercept form is y equals mx plus b. So m is the slope of the line and b is the y-intercept. Now we can find the slope of the tangent from the derivative of the function. The slope of the tangent is equal to the value of the derivative at x equals pi over 4. So let's start by finding the slope. So it is equal to the derivative of the function, and the function is tan x and the derivative of tan is secant square x. Now we can sub in x as pi over 4. Now we have to evaluate this expression. Now we know that secant is the reciprocal ratio for cos. So we can rewrite this expression as so secant square can be written as 1 over cos square. Now this is square of cos pi over 4, and we know cos pi over 4 is equal to 1 over square root 2. And we put the square on 1 over square root 2. Now 1 over square root 2 square means we have to multiply 1 over square root 2 by itself, and 1 over square root 2 times 1 over square root 2 will be equal to 1 over 2. So it becomes m equals 1 over 1 over 2. Now we can evaluate this expression by writing it as a division statement. Now we can convert this division statement into a multiplication statement. When we do that, we flip the fraction written after the division sign, and 2 divided by 1 is 2 and 1 times 2 is 2. So that means the slope of the tangent is 2, and we can sub in this m value in our general equation. Now we have to find the value of b, and for that we need a point that lies on this tangent. Now we have to find the equation of the tangent at x equals pi over 4. So if we sub in x as pi over 4 in the given function equation, we can find the point that lies on the tangent. So we should sub in x as pi over 4 in f at x. And tan pi over 4 is equal to 1. So a point that lies on this tangent is so now we can sub in this point in this tangent equation as x and y, because this point is the point where the tangent touches this function, so this point also lies on the tangent. So we'll sub in x as pi over 4 and y as 1. Now we can simplify 2 times pi over 4. So we get 2 pi over 4, which is reduced to pi over 2. And we can also get pi over 2 if we simplify the 2 and the 4. Now we can isolate b by moving pi over 2 to the left side of the equation, and that will make it negative. So this is the y-intercept of this tangent. So the equation of the tangent is y equals, so this is the final answer for part A. Now we can analyze part B. So we have to find the equation of the tangent to the function f at x equals 6 tan x minus tan 2x. So we'll start by writing the general equation of a straight line. Now we can find the slope of the tangent, which is equal to the derivative of the function at x equals 0. Now this function is made up of two terms, and the first term 6 tan x, 6 is the coefficient of the term, so it will stay as it is, and the derivative of tan x is secant square x. And in the second term, we'll have to use chain rule because this term has an outer function tan and the inner function 2x. So we'll start with the derivative of the outer function, and the derivative of tan is secant square times the derivative of the inner function, and the derivative of 2x is 2 times 1. So 2 is the coefficient of the term, so it will stay as it is, and the derivative of x is 1. Now we can simplify this expression. Now in the second part, 2 times 1 is 2, and we can move the 2 to the front of the secant. Now we can find the value of the slope by subbing in x as 0. Now we know that secant is the reciprocal ratio for cos. So in the next step, we can move the secant terms to the denominator to change them to cos, because then it will be easy to evaluate the terms. Now 2 times 0 is 0. And we know that cos of 0 is equal to 1. And 1 square is 1. So we are just left with 6 over 1, which is 6. And then minus 2, which is equal to 4. So the slope of the tangent is 4. Now we can sub in this m value in the general equation. Now we have to find the b value for the tangent, and for that we need a point that lies on the tangent. So we can sub in x as 0 to find the function value at x equals 0, and that point will also lie on this tangent. Now we know that tan of 0 is equal to 0. So we get And then in the second term, 2 times 0 is 0, so tan of 0 is 0. So 6 times 0 is 0, and 0 minus 0 is equal to 0. So the point that lies on the tangent is. Now we can sub in this point in our tangent equation as x and y, and then solve for b. So 0 equals, so 4 times 0 is 0. So therefore b is equal to 0. So that means the equation of tangent is. So this should be the final answer for part B. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.